In this video, I'll work through some sample problems involving Boolean algebra. For this first problem, we're asked to rewrite this logical equivalence in Boolean algebra notation. So what we have to remember is that the logical symbols correspond to Boolean algebra symbols. The AND symbol corresponds to multiplication, the OR symbol corresponds to addition, and the negation symbol corresponds to the prime. We also typically use lowercase letters towards the beginning of the alphabet for Boolean algebra instead of P's and Q's. So instead of P, I'll write A, and becomes multiplication, not Q becomes B prime, and then OR becomes plus, P becomes A, equivalence becomes equality, and then P becomes A again. So there's my Boolean algebra statement that is equivalent to the logical statement. Now we have a similar set equality that we want to rewrite in a corresponding Boolean algebra notation. So again, the set symbols, the set operations, correspond to Boolean algebra operations. Intersection corresponds to multiplication, union corresponds to addition, and then complement corresponds to prime. So again, we use lowercase letters, so capital A becomes little a, intersection becomes multiplication, B prime becomes lowercase b prime, union is plus, capital A becomes little a, and then equals little a. So there's my set notation written in Boolean algebra notation. Now finally, we're asked to prove this Boolean algebra equivalence using the properties of Boolean algebra. You can find these properties in table 3-10 of your textbook. And so the way to think about this is to try to think about how to get from the left-hand side to the right-hand side using the various different equivalences that we have. So it might help to try to look for something like what you have in the table of equivalences. So in this case, what we have is A plus B multiplied by B plus C. So we have two things multiplied together, and each of those parentheses is a sum. And if we look, we see something like that in the distributive property. So the distributive property in our table says that A plus B times C is equal to A plus B times A plus C. And that's kind of like what we have, except we have A plus B and B plus C. So what you want to notice is that the first things in each of these parentheses has to be the same, because that's what you distributed when you did your addition through that set of multiplication. So the first thing we have to do is take our A plus B and our B plus C and rewrite it so that the first thing in both parentheses is the same, which means we're going to have to switch around the first set of parentheses to write this as B plus A times B plus C. And so that's going to be using the commutative property of addition. Now that we've made the first thing in each parentheses the same, we can essentially undistribute. So we get B plus parentheses A times C using our distributive property. And now it's almost what we have. Again, what we want to get is AC plus B. So all we have to do is now use commutativity one more time to rewrite this as A times C plus B. That's again using commutativity of addition. And that gets us the equivalence that we want.